The purpose of this video is to help with MCO556 LAB2 getting started with MCUXpresso IDE. Now, required hardware and software provided as Seneca Labs tells about actually running Windows 11 currently, and it has MCUXpresso IDE 11.4.0 under My Apps, but you'll also find the more current one, MCUXpresso, that's more current to 2026. Now, the lab itself goes through objectives, glossary, but it's on the second page where we're going to actually start cloning a demo program called Hello World, and we're going to be doing some modifications of that. And by clicking on this link, that's how you're watching this video now, and it takes you through all the various aspects that you need to know about here. It's important before you start using MCUXpresso that you actually set up on your own drive someplace like MCO556 Labs and your workspace, because this way, if all your stuff gets put on your memory stick when you go from the lab to home and home to the lab, you'll always have the same files available. Now it's going to have a default workspace on the C drive. I'm going to switch over to where I've got it on my drive. I'm just going to say Browse onto MCO556 Labs and select my workspace. And from now on, all of the stuff that I'm going to create is going to be stored on my workspace drive that I can take home and use as well. Now at this point, we can go to IDE. And when we do, we can see this screen here. It mentions in the notes about the Quick Start menu, which is down here at the bottom, IDE Quick Start. And we have up here Import SDK Examples. We also have down here Import SDK Examples. You can use either one. And if we click on this, we want to make sure we select this guy here because of all these boards, this is one we're using. We click on this. Let's hit Next. And down here we have a list of various things that we can upload. And we're going to take a look right now at demo apps. We have a whole bunch of demo apps in here. But the one that it mentions in the notes is Hello World. So we're just going to click on this. And then we're going to say Next. And we're going to see that it's going to use Flash for programming. It's going to use RAM and so forth. And it tells you the addresses and stuff here, but we're just going to hit Finish. And when it's finished, one of the things we want to do is we can take a look at the helloworld.c file, which is here. We can also change the name of this. I'm going to right mouse click here, and I'm going to go down to rename. And instead of just calling it Freedom K64 Hello World, I'm going to call it Hello World Rev 0 because we're going to make a number of different revisions to this. So this is Rev 0. And I'm just going to say OK. And all of this, because we've set up our things on our memory stick, everything is going to go there. And again, we've got a brand new name here. And then we have, as I said, their source. We can take a look at that. There's our Hello World there. Now, there's a couple of things we have to do to make this work. Number one, we have to make sure that our Freedom K64 is plugged in at this time. And we have a number of options we can do down here. As you can see, we can build, clean, or debug. Clean is if you've got something that's maybe needs to be completely revamped from the beginning, because sometimes when you compile it and then you may have to recompile certain parts that it didn't. So cleaning is a good option here. You can do a build, and it's going to give you this freestanding found list of compilation flags and stuff, but you don't care about, so you're just going to say OK. So when you do the compile, you're going to see all this stuff happening, and we should have 0 errors, 0 warnings. And it took only 7 seconds. So the next thing we want to do is debug. Now you can either hit debug here, or you can go up to the screen here and hit it here. Either is good. And we can just say OK. And it should find our probes, which is our Freedom K64's DAP link. And it should do a build. And now it's finished. And what it's doing is it's bringing up this part of our code here, which is our helloworld.c file here. It has some includes. FSL stands for Freescale Device Registers, Debug Console, Pin Mux, which we're going to learn about later, Clock Configure, and Board.h. So where it's actually starting our code is down here. And one of the things you're going to notice in our code here is it's using a capital PRINTF and a capital PUTCHAR and GETCHAR. And this is because this debugger takes the lowercase version and converts into uppercase. What we want to do is actually set up a terminal here. What we can do is go up here to Window. We can go to Show View, and we can go down here to Other, and we can pick up Terminal, click on Terminal, and we can say Open. And you can see over here, we've got this little screen here, Open a Terminal. And what we're going to do is choose a terminal, and our terminal is going to be Serial Terminal. Now what we have to do is check all of this to make sure that Windows is compatible with what we've got here that's set up the same way. So we're just going to right mouse click, go to Device Manager, check to make sure that everything lines up here. So we're going to go to Ports and COM port, and it is COM port 9. So we look here, COM port 9, and our speed is going to be 115 to 100, 8 bits, no parity, and everything should work fine. So as we start tracing through here, and that's this button up here, as you can see in the notes, this is step over, step into, and step return, and so forth. So we have to initialize our board boot pins. Then we're going to go on to the next step here, which is initialize or debug console. And then once we go here, it should say PRINTF when we go to the next step. And notice it didn't do it when it was on here, only when it goes to the next line. At this point, it's ready for us to start typing stuff in. So if I hit the arrow key, I'm running now. I have to click in the window. I can say, hi there, how are you? Nice whole typewriter. But when I hit the enter key, it goes back to the start of the same line. So this isn't great because we want it to go to the start of a new line. So here's what we're going to do. We're going to make some modifications. And what we're going to do before we make the revisions is we're going to go up here and we're going to say right mouse click. We're going to go copy. We're going to go right back to here. We're going to say paste. And it's already going to know down here that we want to make it Rev1. So I'm going to copy that. And we've got two versions of our program. We've got the original one up here, which I can make a little bit smaller. We've got this other version here where we can now build on what we've done already. We can go to our source file that's here. Notice our debug launch here was from the Rev0. So I'm going to right mouse click and I'm going to delete that because once we do this, we'll have a different one for this newer version. One of the other things we can do here with Rev0 is because we don't want to work with it, is we can go up here and we come down here and we can say close project. So we make sure we don't mess around with it. Now that we've done that, what we want to do is go here and make a couple small changes. And so this is getting a character. When we get a character, we're going to say if character is equal, notice it's double equals to, and the thing that we're typing in is a /R, which is also a 0x0d, which is our carriage return. What we want to do is go down here and say printf, has to be capital now, and then we're going to say quote /R /n. /R is a carriage return, which is the same as a 0x0d. And /n is the line feed. So carriage return line feed is going to move us down. And it's going to say, if this is true, it's going to do this. Otherwise, it's just going to put out a character. So if it's not this special case, it's just going to put out a regular character. And all we have to do at this point is, first of all, terminate our existing code because it's still trying to run the one for Hello World Rev0. We're going to hit the big square red thing here. And once it's out, we're going to then compile and debug this. So we're just going to hit this and we're going to say OK. And it's going to now download the new version. Notice it also created a Rev1 here. And it's going to say, do you want to save this? And I'm going to say yes, because we made some changes. It's going to give us that message again. And we can just say OK and let it go. And it's going to put all this stuff down here and it's going to run it now. And it should make that modification. So it should go to a new line every time I run it. When it's finished, we can again, just for fun, do this tracing. And we want to make sure we switch over to terminal here. Let's take a look at here. We're going to step over, step over, step over, and then see printf hello world. There we go, hello world again. And it's ready for us to now start typing. We have to hit the run button. So you hit the run button. We're going to say HI space there, enter. And you can see that it goes to a new line, which is great. One other thing that we can find is if we're typing in here and we hit the back button, notice we get some funny stuff happening here. Because what we're really typing in is a delete character, which is a 7F, and we want to echo that as a backspace, which is a 08. So we're going to make some other changes to this. And before we do, we've got this one working fine now for what it does, but we're going to do again a right mouse click. We're going to go down here. We're going to say copy. We're going to go right up here again and say paste. And already it's called it Rev2, and we're going to say copy that. And again, we're going to have two programs here. And what we're going to do is, because we want to use the Rev2, we're going to close project. We're going to go down here and notice that it's duplicated it. Going to have exactly the same Rev1 here. So we're going to have to delete that and let it create a new one. You should also notice that it's producing something here called a MEX file. We'll talk about that later. And we're going to make the changes to this in our source file here again. Now let's take a look at the changes we put in. We're getting a character from the keyboard. If the character is a 0x0d, which is an enter or carriage return key, or /R, it's going to print also the carriage return and a line feed to move us back to the start of the same line and down. And it says if we happen to hit the back key, which is mapped to a delete, then what we want to do is put out a 08, which is going to actually back up as well. And so if it's this, it does this, else if it's this, it does this, else it just puts out a regular character. So let's try running this and seeing what happens. And it's going to ask us, do we want to make changes? We're going to say okay, because we want to make changes to our code because we put these changes in. It's got the red link multi-driver going, which is connecting us to the board and downloading our code into the board. And now it's ready to go. So we're going to switch back to terminal here. And we're going to then just step over these two. And then when we step here, it hasn't printed hello world until we step off it. And there's our hello world. And if we run now, we can type in stuff like, hi there, how are you? Question mark, and it does that. And we can hit the backup key like this, and it's going to make corrections. So that's all working fine. Now, there's something else that you should be aware of, and ANSI escape sequences. So if I do an escape, left square bracket, 2, Shift J, it's going to clear the whole screen. If I do an escape, left square bracket 1, semicolon 1, capital H, it's going to position me in the top left. If I do an escape, left square bracket 31, small m, it's going to now allow me to type in red. And if I do an escape, left square bracket 1, small m, it's going to make that now bold red. And we can do escape, left square bracket 32m, and allows me to type in green. Plus, you have not only the ability to clear the screen and change text colors, you can actually do escape, left square bracket 12, semicolon 40, capital H, and it's going to position us 12 rows down and 40 columns over.